let's go ahead from the chapter 6.6 in the 4th grade math book. Look at page 143 workbook. Section 4 asks you to express a whole number as an improper fraction with a particular denominator. So A has given us the denominator of 9. Our goal here is to represent 2 wholes as an improper fraction. So if we look at or consider what one whole would represent, we know that one whole would represent having the same number as the numerator as we have as the denominator. So right now, our denominator is 9. If we had a whole, we would have all 9 pieces represented. So 9 over 9 represents one whole. We need to have 2 wholes. So we could go ahead and add another 9 over 9. In order to figure out one improper fraction that represents both of them, we need to combine them. And we're only combining the numerators because we're not changing the number of pieces that are needed to make our whole. And 9 plus 9 is 18, giving us our improper fraction for that whole number. So let's take a peek at B now. If we look over at B, we are trying to represent 3 wholes, and they've given us a denominator of 8. So if we go ahead and create our first whole, which would be 8 over 8, meaning we have all 8 pieces of the 8 pieces that we need, and we need to figure out what 3 of them would represent. You know that your denominator is going to stay the same. Could we write it out as 8 over 8 plus 8 over 8 plus 8 over 8? Yes. But you could also say that's repeated addition of 8 3 times, which is the same as 8 times 3. Your numerator is going to change, your denominator is going to stay the same. So if we can take 8 and add it to itself 3 times, we should have the number of numerator pieces that are needed to create 3 wholes. 8 times 3 is 24. And it does indeed represent 3 wholes. Let's see another one of those with C. So we're talking about the whole 4, and we are going to create an improper fraction with 5 as our denominator. I know that one whole represents or is represented by 5 over 5, and I need 4 of these. So remember, our denominator doesn't change. We could technically do this 4 times because we're looking for 4 wholes, or we could take the number of pieces that are needed in our numerator when we're representing a whole and multiply it by the number of wholes we're trying to get. 5 times 4, because we're looking for 4 wholes, is 20.